Imagine you're holding a rock in your hand. Just a normal, everyday, solid gray rock you picked up off the dirt.
Okay, I'm picturing it.
Right, so you're holding this rock, and you ask yourself a question that, honestly, any curious 5-year-old might ask.
Which is?
What happens if I smash this rock in half? And then I take that half and I cut it in half again.
Oh, I see where you're going with this.
Yeah, and you just keep cutting the halves into halves over and over again forever. Can you actually do that?
Right, like, is matter infinitely divisible?
Exactly. Do you eventually hit a wall? Like, do you eventually hit a pixel of the universe that is just completely uncuttable?
It sounds like such a simple child's riddle, but that specific question is literally the structural foundation of modern physics.
Wait, really? Just the idea of cutting a rock?
Absolutely, because if you assume you can cut that rock forever, the mathematics that govern our universe actually break down. Yeah, but if you assume you hit a wall, a fundamental, like, grain of reality, you open the door to everything from quantum mechanics to the absolute frontier of science today.
You mean quantum gravity?
Exactly, quantum gravity.
And it's so funny because usually when we talk about quantum gravity or, smashing subatomic particles, we immediately picture this incredibly specific setting.
Let me guess. A multi-billion-dollar super collider under the Swiss Alps.
Yes, exactly. We picture this sterile, pristine laboratory in the 21st century.
Lots of glowing screens.
Right, massive server farms, scientists in white coats staring at these complex data readouts. We just have this deep-seated assumption that to ask the biggest questions about the universe, you need the most advanced modern hardware.
There's definitely an inherent presumption of technology there.
Yeah.
We just naturally assume that to understand the invisible building blocks of reality, humanity first needed to invent lasers or electron microscopes.
Or particle accelerators.
Right, we view it as a purely modern post-industrial thing.
But then, if you actually crack open the history of physics specifically, the historical roots of quantum mechanics, that high-tech Swiss laboratory just completely vanishes.
It's not in the 21st century at all.
No, not even close. We are standing in the dust of an ancient Greek trading hub 2,600 years ago.
Wearing tunics.
Listening to citizens debate in a public square. So today, for this deep dive, we are pulling from Carlo Rovelli's amazing exploration of quantum gravity, the book called Reality is Not What It Seems.
Such a fantastic source.
It really is. And our mission today is to trace this sort of time-traveling detective story. We're going to show you how that single, simple question about cutting a rock completely reshaped human knowledge.
And how it survived millennia of suppression, too.
Right, and how it laid the exact mathematical and philosophical groundwork required to solve the deepest mysteries of the cosmos today.
The stakes of this historical journey are just incredibly high. These ideas aren't just trivia.
No, definitely not.
To really understand what physicists are doing right now today trying to merge gravity with the quantum world, we have to look at the exact moment when humanity decided to stop blaming the gods for how the world works.
And actually started using reason.
Precisely. Using reason to find the hidden architecture of nature.
So let's transport ourselves to that exact moment. We're going back at the dawn of the 5th century BC to a city called Miletus.
Miletus. Such a crucial place.
Yeah, and this isn't just a random spot on a map. If we are looking for the absolute genesis of scientific thought, we have to look at the geography and the culture of this specific city.
Right, because Miletus was this wildly prosperous Greek city located on the coast of Ionia, which is modern-day Turkey.
Okay.
And before the legendary golden ages of Athens and Sparta, Miletus was arguably the most vibrant city in the Greek world.
Wow, really? Bigger than Athens?
At that specific time, intellectually and commercially, yes. It was a powerhouse of trade. It was this crucial node in a network of nearly 100 colonies and trading posts.
Well, that's massive.
It stretched all the way from the shores of the Black Sea right down to the coast of North Africa.
So you have to imagine this bustling, incredibly cosmopolitan seaport.
Endless ships and caravans.
Right, you've got caravans arriving daily overland from Mesopotamia, bringing centuries of Babylonian astronomy with them.
Detailed star charts, advanced mathematics.
Exactly. And at the exact same time, you've got ships sailing in from the south, bringing ancient Egyptian engineering, geometry, architectural knowledge.
It's a complete melting pot.
It really is. You have different cultures, different languages, and this is the key part, different mythologies all crashing into each other in the marketplace.
That collision of mythologies is the absolute catalyst.
How so?
Well, think about it. For thousands and thousands of years prior to this moment, Human beings everywhere explain the natural world in essentially the exact same way.
Through stories.
Yes, from the cuneiform tablets of Sumeria to ancient Chinese texts, from Egyptian hieroglyphs to indigenous oral traditions globally.
We relied on these elaborate myths.
Right. We explain the world through, feathered serpents or celestial cows giving birth to the sun.
Or God standing over a dark void saying, "Let there be light."
Exactly. Or the universe hatching from a giant stone egg.
Which, to be fair, those are incredibly poetic stories.
Oh, they're beautiful.
Yeah, they give a society a shared narrative, and they probably help people sleep at night in a terrifying, unpredictable world.
But they aren't testable mechanisms.
No, they're definitely not. If lightning strikes your house and burns it down, and the culturally accepted explanation is, well, Zeus was angry today.
The investigation stops right there.
Exactly. There's no follow-up question. You can't measure Zeus's anger.
You can't predict it.
Nope. You just offer a sacrifice and hope for the best.
It was a completely closed loop of knowledge. The explanation for everything was divine will, which is inherently mysterious and beyond human comprehension.
But in Miletus, around the 6th and 5th centuries BC, this fundamental cognitive shift happened.
The Lycian Enlightenment.
Yes. A group of thinkers, starting with a guy named Thales, followed by his brilliant student Anaximander, and others like Hecataeus, they discovered a radically different way to interrogate the world.
They realized they didn't have to rely on imagination or myths or the unquestionable authority of priests anymore.
They could use observation and reason.
And critical thinking to uncover a hidden order.
The way I sort of conceptualize this shift is like humanity upgrading its operating system.
I like that analogy.
Yeah, like for millennia, we were running on Superstition 1.0.
Right, very buggy.
Super buggy. It was unpredictable, and it relied entirely on these invisible wizards pulling levers behind the curtain. And then Miletus rolls out open source reality.
Open source reality, that's perfect.
Suddenly, people realize they don't have to just accept the wizard. They can look for the man behind the curtain. They can search for the actual physical mechanisms that drive reality.
And the open source aspect of your analogy is really the most vital part of this whole revolution.
Because they shared the information.
Partially, but mostly because the true breakthrough wasn't just the specific answers they came up with. I mean, some of their answers were completely wrong.
Sure.
It was the invention of a new method. It was the democratization of truth.
Okay, unpack that a bit.
If you look at the historical record, Anaximander emerges as an absolute giant of this era. Using nothing but this new method of observation and logic, within just a few short years, Anaximander deduced things that are, frankly, astonishing.
Oh, let's definitely dig into Anaximander's specific deductions because they blow my mind every time I read about them.
They really are incredible.
How does a guy in a tunic without a telescope figure out the architecture of the solar system?
Well, consider what everyone believed at the time. The Earth is a flat disk, and the sky is a solid dome above it.
Right. And the Earth has to be resting on something.
Exactly. Maybe it rests on giant pillars or a cosmic turtle, or it floats on an infinite ocean. But Anaximander went out and observed the night sky meticulously.
Just watching the stars.
Just watching. He noticed that the stars don't just move across the sky and stop. They rotate around a central point.
The pole star.
Right. And, crucially, he observed that certain constellations disappear below the horizon and then reappear on the exact opposite side.
So he realizes they aren't just vanishing into thin air.
No, they are completing a full circle.
And for a circle to be completed, those stars must be passing literally underneath the Earth.
Precisely. And the cognitive leap here is just staggering.
It really is.
He deduced that if the stars can pass underneath us, then there cannot be an infinite ocean or endless pillars holding the Earth up.
Because the stars would crash into them.
Exactly. There must be empty space down there, too. Therefore, the Earth is a finite object floating in a void, surrounded by the heavens on all sides.
It's just brilliant. He realized the Earth doesn't need to be held up by anything because there is no universal down in space.
Right. Things fall toward the Earth,
Uh-huh.
but the Earth itself is just suspended in the center.
To look at the dirt beneath your feet, feel gravity pulling you down, and yet logically deduce, yes, we are actually a rock floating in an infinite void.
It's one of the greatest triumphs of human logic.
Without a doubt. And he didn't stop there. He tackled the weather too, right?
He did. He realized that rain isn't the tears of a god or water leaking through cracks in a celestial dome.
Because he watched the water cycle.
He observed the sun heating water, the formation of mist, and deduced the whole cycle of evaporation and precipitation.
Unbelievable.
He even proposed that all the endless variety of substances in the world Wood, rock, water, flesh might actually be reduced to a single underlying invisible constituent.
He called it the aperon, right?
Yes, the aperon or the boundless.
So he's essentially predicting a fundamental element.
Yes, and perhaps most shockingly, he posited that animals and plants evolve and adapt to changes in their environment.
Wait, evolution? In ancient Greece?
Yes, he noted that human infants are incredibly vulnerable. They require years of care. So he reasoned that the very first humans couldn't have survived if they just popped into existence as infants.
That makes perfect logical sense.
Therefore, humans must have evolved from other animals that mature much faster. He specifically suggested we originated from fish-like creatures in the ancient oceans.
He is sitting there, thousands of years before Charles Darwin boards the HMS Beagle, casually mapping out biological evolution and common descent.
It's almost eerie how close he got.
It really begs the question, though. How did this one specific city foster so much intellectual horsepower?
It comes back to that method of critical discourse. Before the Milesian thinkers, a student's primary job was just to memorize the master's teachings.
And repeat them flawlessly, I assume.
Exactly. The knowledge was sacred. To question your teacher was basically a form of heresy.
But in Miletus, that changed.
Completely. A student was allowed, even actively encouraged, to take their teacher's ideas, keep the parts that worked, and mercilessly critique the flaws.
So it wasn't disrespectful to disagree.
Not at all. Anaximander profoundly respected his teacher, Thales, but he openly corrected Thales' assertion that the earth floated on water.
It's the realization that knowledge isn't this sacred, fragile relic handed down from on high. It's a building under construction.
Yes, perfect analogy.
You can add a new floor, and if you realize a load-bearing wall from the previous generation is structurally unsound, you just knock it down and rebuild it better.
That skepticism permeated everything they did. There's this brilliant quote from Hecataeus, who was a Milesian writer focusing on history and geography.
What did he say?
He essentially prefaces his entire body of work by stating, "I write these things as they seem true to me. For the stories told by the Greeks are various and, in my opinion, ridiculous."
Oh, I love that so much. He's essentially saying, with all due respect to Homer, I'm going to rely on facts.
Exactly. It is a breathtaking level of rational skepticism.
And there's another incredible example of this skepticism involving a philosopher named Heraclitus.
Oh, the trip to Hades.
Yes. The prevailing myth in Greece was that the great hero Heracles had descended into the underworld Hades through a physical, literal cave at a place called Cape Teneron.
And for generations, people just accepted this as a geographical fact. It was common knowledge.
Right. And Heraclitus decides to employ this new tool of empiricism. He actually travels to Cape Teneron. He doesn't just read the scrolls. He goes to the physical location.
He explores the area, looks at the caves, investigates the terrain, and concludes, there is no gateway to the underworld here. The legend is false.
He literally fact-checked a myth.
He walked up to what was supposed to be the actual gates of hell, realized it was just a regular rocky beach, and called it out.
It's so bold.
But this level of free inquiry raises an important sociological question for me. Why there?
You mean why in Miletus?
Yeah. Human brains have been biologically identical for roughly 200,000 years. Why did this intellectual lightning strike in this specific port city in the 5th century BC and not somewhere else earlier?
Historians actually attribute this directly to the unique political and social environment of Miletus.
Okay, break that down.
Remember, it's geography. It was on the border of the emerging, fragmented Greek civilization and the ancient, massive, centralized empires of Mesopotamia and Egypt.
Right.
So Miletus absorbed their vast astronomical data and mathematical tools, but it did not adopt their oppressive social hierarchies. Meaning, they got the data without the dogma.
Exactly. There were no colossal, intimidating imperial palaces in Miletus. There was no absolute monarch claiming divine right.
And no powerful priests.
Crucially, no entrenched, overwhelmingly powerful caste of priests guarding the truth. The citizens lived in an atmosphere of relative political fluidity.
So they were self-governing.
Yes. They governed themselves by gathering in open public spaces, the agoras, to debate their laws, their trade agreements, and their destiny.
Oh, wow.
They even formed the first recorded parliament in history, the Panionic League.
This is such a crucial connection. If your society operates on the premise that the best laws and decisions come from human beings arguing, debating, and reaching a consensus in a public square.
Rather than from a king interpreting the will of a sun god.
Exactly. It's a very short conceptual hop to apply that to the universe. If human debate determines the laws of the city, maybe human debate can determine the laws of nature.
If the gods don't micromanage our taxes, maybe they don't micromanage the thunderstorms either.
That is the exact psychological leap. It was this golden, fleeting moment in human history. The human mind waking up to its own capacity to decode the universe.
But unfortunately, if you read any ancient history, you know that golden ages rarely last.
They really don't.
The Milesian Enlightenment met a brutal, sudden, and devastating end.
What happened?
In 494 BC, the sprawling Persian Empire, attempting to crush an anti-imperial revolt in Ionia, completely destroyed Miletus.
Completely destroyed it.
Razed it to the ground. The Persian army slaughtered the men and enslaved the women and children.
That is horrific.
It was such a profound apocalyptic trauma to the Greek world that when a playwright named Phrynichus produced a tragedy in Athens titled The Capture of Miletus, the reaction was unprecedented.
What did the audience do?
The audience wept so hysterically that the Athenian authorities actually banned the play from ever being performed again.
You're kidding.
No, they banned it. And they even fined the playwright for reminding them of such a deep sorrow.
They literally banned the theatrical adaptation because the real-world trauma was just too much to bear.
It was a collective psychological wound.
So the physical city is gone, the buildings are ash, the population is enslaved or scattered. It seems like the Persian Empire just snuffed out the flame of science before it could even really catch fire.
It certainly seemed that way. But ideas, once they are unleashed, are incredibly difficult to kill.
They survive in the people.
Yes, the physical infrastructure of Miletus was destroyed, but the intellectual spark, that specific method of rational inquiry, survived in the minds of the refugees who fled the destruction.
Okay, so where do they go?
Around 450 BC, a man named Leucippus boarded a ship, fleeing the political turmoil of a tentatively rebuilding Miletus. He sailed north to a city called Abdera.
Abdera.
And in his mind, he carried the seed of an idea that would eventually grow into the most consequential scientific concept in the history of humanity.
So Leucippus lands in Abdera, and he sets up shop. He founds a philosophical and scientific school, carrying on that Milesian tradition, and there he takes on a young student named Democritus. Now, Democritus is not just a minor historical footnote, right? If we look at the contemporary accounts, this guy was an intellectual titan.
Democritus was a polymath of the highest order. The historical record shows that later figures, like Seneca, praised his impossibly sharp mind.
And Cicero, too, right?
Yes, Cicero asked rhetorically, who could possibly be compared to Democritus in greatness of intellect?
Wow.
He wrote dozens of books, none of which survive today, which is a tragedy we will discuss later. But they covered physics, ethics, politics, cosmology, language, agriculture, and religion.
And together, the teacher Leucippus and the student Democritus attempt to fulfill Anaximander's ultimate dream, finding the single fundamental constituent of nature.
And they absolutely nail it.
They do. They arrive at this grand, sweeping theory of reality that is so startlingly modern, it honestly gives you vertigo.
They proposed an incredibly elegant, minimalist, and infinitely powerful system.
What was it?
Democritus declared that the entire vast complexity of the universe consists of only two fundamental things: boundless, infinite space, which he called the void, and countless, indivisible particles moving through that space.
And he called those particles atoms.
Exactly. Which literally translates from ancient Greek as uncuttable.
Uncuttable. So, going back to our rock from the intro, if you keep cutting that rock, Democritus says, yes, you eventually hit a wall.
You hit a tiny, solid chunk of reality that cannot be divided any further.
But this is where the theory gets profoundly deep and honestly a little bit counterintuitive for our daily experience of the world.
It does require a massive leap in abstract thought.
Right, because Democritus argued that these atoms do not possess the qualities of the objects they make up.
This is a crucial distinction. Democritus realized that our human senses are easily fooled. We misinterpret things all the time.
Sure, optical illusions, things like that.
Right. Therefore, he argued, the fundamental building blocks of reality cannot rely on subjective human senses. He stated that atoms have no weight, no color, no taste, no smell, and no temperature.
So what do they have?
They possess only geometric properties, shape and size.
That's it.
That's it. There is a famous, brilliant fragment from Democritus that survives. It goes, sweet is by convention, bitter by convention, hot by convention, cold by convention, color by convention. In reality, there are only atoms and the void.
Let's really think about what he's saying there. He's saying, look at a bright red apple. The apple itself isn't actually red.
Redness isn't a physical property of the object.
Right. Redness doesn't exist out there in the objective universe. The apple is just a complex structure of colorless geometric shapes.
Exactly.
And when light bounces off those shapes and interacts with the specific atomic structure of the retina in your eye, your brain hallucinates the subjective concept of red.
He is essentially inventing the foundation of modern neuroscience and particle physics simultaneously.
It's mind-blowing.
Yes, he is distinguishing between what philosophers later called primary qualities, which is objective, mathematical reality, and secondary qualities, which are merely human perceptual experiences.
Okay, so we have these invisible geometric atoms. What are they doing?
He proposed that these indivisible geometric atoms fly freely through the infinite void. They crash into each other, they hook together, they pull, they push, they rebound.
Constant motion.
Constant motion. And every single thing that exists in the entire universe is nothing more than a random, purposeless combination of these geometric shapes colliding and linking up.
Democritus actually came up with an analogy for this combining process that is so perfect it's still used by chemists today. He compared the atoms to the letters of the alphabet.
It's an exquisitely powerful metaphor.
Yeah.
Think of the 26 letters of the English alphabet. They're just distinct shapes.
A, B, C, D. Just lines and curves.
Right. But by taking those exact same letters and merely rearranging their order and structure, you can write a hilarious comedy, a devastating tragedy, a dense scientific manual, or an epic poem.
The letters themselves don't change.
Not at all. The building blocks remain identical. The only thing that dictates the nature of the final product is the structural arrangement.
And if we apply that to chemistry, it's exactly how the periodic table works. You take 2 atoms of hydrogen and 1 of oxygen and you get water.
A liquid that puts out fires.
Right, but you rearrange those exact same types of atoms with some carbon, and you can build a highly flammable rocket fuel.
The underlying constituents are the same.
Democritus is saying the universe works exactly the same way. The atoms that make up a rock are the same kind of atoms that make up a drop of water or a cloud or a distant star.
Or a human being.
Right.
This is where the philosophy becomes incredibly radical. Democritus explicitly stated that our bodies, our lives, our thoughts, our dreams, our consciousness, and our emotions are all just temporary, fleeting arrangements of these eternal atoms.
Just temporary arrangements.
Yes. It is a profoundly materialistic, naturalistic view of the cosmos. There is no grand design. There is no ultimate end goal.
The infinite dance of atoms has no purpose.
None. Nature is simply experimenting with forms and structures over eons of time through trial and error, and humanity is just one of the random, temporary results of that eternal shuffling.
Okay, I have to jump in here and push back a little because I can hear you, the listener, thinking it, and honestly, it's a very natural human reaction.
Push back away.
Isn't this worldview incredibly bleak? I mean, if everything my hopes, my deep love for my family, my dreams for the future, my sense of morality is just the accidental byproduct of a random cosmic pinball machine of shape-shifting geometry with zero ultimate purpose, doesn't that strip all the magic, mystery, and meaning out of life?
It sounds cold and isolating.
Very cold. It makes me feel like a temporary glitch in a giant machine.
It is a very natural reaction to feel a sense of existential dread when confronted with a purely materialistic universe, and is the exact reaction that many powerful thinkers had at the time.
I can imagine.
But it's vital to understand that Democritus himself didn't see it as bleak at all. In fact, he found it intensely liberating.
Liberating.
He built an entire ethical framework upon this physics, aiming for what he called euthymia, which is a serene, balanced, and cheerful mind.
Oh, hey, wait. How does realizing you are a meaningless collection of atoms make you cheerful?
Because it frees you from the suffocating terror of the supernatural.
Oh.
Remember the historical context. The prevailing belief was that your daily life, your health, your harvest, and your ultimate fate were constantly at the mercy of capricious, easily angered, petty gods.
Right, gods who demanded sacrifices and might strike you down with a plague or a lightning bolt simply because you didn't appease them correctly.
Exactly. And worse, there was the constant looming threat of eternal torment in the underworld after you die.
So it removes the anxiety of being constantly judged by an invisible jury.
Yes. Democritus essentially said, relax. The gods aren't micromanaging your life. There's no divine punishment. There's no terrifying underworld waiting to torture you.
Because it's just atoms.
Right. When you die, your atoms simply disperse back into the beautiful infinite void to become something else. A flower, a breeze, a star. We are fully integrated parts of nature, woven from the exact same thread as the cosmos itself.
That actually is quite beautiful when you put it that way.
For Democritus, this realization brought a profound sense of inner peace. It removed the anxiety of the supernatural and allowed a person to focus on living a good, balanced, natural life.
Finding deep beauty in the infinite, chaotic dance of reality.
Exactly.
So it's less about life being meaningless and more about life being remarkably, beautifully natural. We belong here, literally down to our atoms. We aren't strangers in a hostile realm run by angry dictators. We are the universe experiencing itself.
That's a great way to summarize it.
But as beautiful as that sentiment might be to a modern scientific mind, it was a deeply threatening idea to the establishment. And this brings us to the massive intellectual backlash.
So the backlash was severe.
Democritus had some serious enemies, and not just random critics. Some of the most famous, influential names in Western philosophy actively tried to destroy his ideas.
Yes. The historical narrative makes it clear that both Plato and Aristotle, the two towering figures whose ideas would dominate Western thought for the next 2 millennia, were deeply, fundamentally opposed to Democritus's vision.
And their opposition, unfortunately, derailed the progress of physical science for centuries.
So you simply could not accept a universe without a central purpose. They championed an idea called teleology.
Teleology. Break that down for us. What does that mean?
Teleology is the belief that everything in nature happens for a specific end goal or purpose, usually directed by a higher power or an inherent objective good.
Okay.
In a teleological universe, a seed grows into a tree because it desires to fulfill its purpose of becoming a tree. Rain falls because the earth needs nourishment.
It's projecting human motivation onto inanimate objects.
Exactly. And the historical texts give a great example of this clash from Plato's famous dialogue, the Phaedo.
Oh, I've heard of this one. What happens in it?
In it, Socrates is complaining about these new physicists who are trying to explain the world through material causes. Socrates says he used to be interested in physics, but he got incredibly frustrated because when the physicists tried to explain why the earth was round, they just talked about matter clumping together.
Right, gravity and accretion.
But they didn't explain why it was good for the earth to be round.
Good. Like morally good.
Yes, or aesthetically good. Plato demanded that a scientific explanation had to include a moral or aesthetic justification. He wanted to hear that the earth is a sphere because a sphere is the most perfect symmetrical geometric shape.
And the divine creator wanted the world to be perfect.
Right. If a physicist like Democritus just said, well, the earth is round because chunks of matter randomly collided in a void and gravity smoothed them out over time, Plato found that utterly unacceptable. It lacked a comforting, purposeful narrative.
It's like Plato wanted the universe to be a beautifully written fantasy novel with a clear hero, a clear moral, and a tidy ending.
And Democritus was handing him a brutal, dry, objective instruction manual.
Plato actually hated Democritus so intensely that he refused to even cite him by name in his writings. Modern scholars think it was a deliberate, petty snub.
There were even historical rumors that Plato wanted to burn all of Democritus's books.
That is wild. But despite the powerful haters, Democritus's theory of the atom is astonishingly accurate, which brings up the biggest, most glaring mystery for me in this whole story.
Who would he know?
Right. How on earth did he know? He didn't have an electron microscope. He wasn't firing lasers at gold foil like Ernest Rutherford. He had no advanced metallurgy, no chemical reagents, no electricity.
Nothing but his mind.
How could a guy sitting in a toga in ancient Greece accurately deduce the subatomic structure of reality?
That is the pivotal question of the entire era. He deduced it by confronting one of the most maddening mathematical and philosophical puzzles in human history, the problem of infinity.
Infinity, yeah.
And to set the stage for how monumental Democritus's logical deduction was, we should consider a famous quote from Richard Feynman.
Oh, Feynman. And for any listeners who might not be familiar, Richard Feynman was one of the most brilliant, charismatic, and influential physicists of the 20th century. He won a Nobel Prize for his foundational work in quantum electrodynamics.
He was a genius at explaining complex ideas.
What did Feynman say about this?
Feynman famously posed a hypothetical scenario in his lectures to his physics students. He asked, if some cataclysm, a vanished build a nuclear war, an asteroid destroyed all of human scientific knowledge.
Okay, a total wipeout.
Right. And you could only pass on one single sentence to the next generation of survivors to help them rebuild. What sentence would convey the most maximum scientific information in the fewest words?
That is an incredibly heavy burden for one sentence.
It really is.
What was his answer?
He said it would be the atomic hypothesis. He phrased it roughly like this. All things are made of atoms, little particles that move around in perpetual motion, attracting each other when they're a little distance apart, but repelling upon being squeezed into one another.
Just that one sentence.
Feynman believed that in that one single sentence, you have the entire conceptual blueprint required to eventually rebuild physics, chemistry, and biology. If you know that, you can figure the rest out.
And Democritus figured out the core of that exact blueprint using nothing but raw, uncompromising logic. So how did he do it? Walk us through the thought process.
Aristotle, despite disagreeing with Democritus, was a meticulous scholar, and he actually recorded the exact logical steps Democritus took.
Okay, what were the steps?
Democritus essentially engaged in a rigorous thought experiment about developing matter. He realized that if you assume matter is a continuous, smooth substance, meaning you can cut it in half forever and ever without ever hitting a limit, you run into an insurmountable, fatal mathematical contradiction.
Okay, let's unpack this contradiction step by step. Let's go back to our rock from the intro.
Right, the gray rock.
I am slicing it in half infinitely. What happens in the math?
If matter is truly infinitely divisible, then let's imagine you finally finish your infinite cutting.
Assuming I have infinite time, sure.
Right. What are you left with? What are the ultimate building blocks of the rock? You cannot be left with tiny pieces that have length, width, and depth.
Because if they had any dimensions at all, by the definition of infinity, I could cut them again.
Exactly. So an infinite division must, logically, leave you with pieces that possess absolutely zero extension. They are zero-dimensional points.
Okay, I follow the logic. I've cut the rock down so much the pieces have no size. They are infinite points of nothingness.
Now, run the film backward. Try to construct a physical three-dimensional universe using your new building blocks.
Okay.
You take a zero-dimensional point, which has zero length, zero width, and zero height, and you add it to another zero-dimensional point. What do you get?
Well, 0 plus 0 is 0. I still have nothing.
Exactly. You can add 3 points, 1,000 points, 1,000,000,000 points, or even an infinite number of zero-dimensional points together, and they will never, ever stack up to create a three-dimensional object with volume.
Because you're just adding 0 over and over again.
You cannot build a solid, tangible universe out of building blocks that possess no size. Therefore, Democritus concluded, the starting assumption must be fundamentally flawed.
Matter cannot be infinitely divisible.
The universe cannot be smooth and continuous. There must be a hard mathematical and physical limit.
There must be grains of reality that have a finite, distinct size.
And physically cannot be cut further. The atom.
This is such a profound realization. Let's use an analogy to really solidify it for you. If you believe the universe is infinitely divisible and continuous, you are essentially trying to build a massive, complex Lego castle using imaginary Lego blocks that have 0 length, 0 width, and 0 height.
That's a great way to picture it.
It's physically impossible to build a castle out of nothing. Democritus is saying, no, eventually when you look close enough, you hit the smallest possible physical Lego brick in the universe.
It might be microscopic, it might be invisible to the human eye, but it is real.
It has physical edges, it takes up space, and it cannot be snapped into a smaller piece.
That is precisely the argument. And it's important to note that this debate wasn't just a casual academic disagreement happening in a vacuum. Democritus was actively, directly battling a rival philosophical school from a town called Elea.
Specifically a philosopher named Zeno, right?
Yes.
Okay.
You've likely heard of Zeno's paradoxes.
Zeno, yes, the guy who loved to use math to prove that motion doesn't actually exist. The famous paradox of Achilles and the tortoise.
Yes. Zeno and the Eleatic school wanted to prove that reality, change, and motion are all illusions, guided by pure abstract rationalism, completely divorced from physical observation.
He weaponized the concept of infinity to trap human logic.
He did. He framed his most famous paradox as a foot race. Imagine the great Greek hero Achilles, the fastest runner in the world, racing a tortoise.
Okay.
Because Achilles is much faster, he generously gives the tortoise a 10-meter head start.
Right.
Zeno argued that logically Achilles can never ever catch the tortoise.
Which sounds completely insane to anyone who's ever watched a fast thing catch a slow thing. We see motion happen every day.
Right.
How did Zeno logically justify that Achilles never catches up?
He used the assumption of continuous, infinitely divisible space. He argued that to catch the tortoise, Achilles first has to run the 10 meters to reach the exact spot where the tortoise started.
Makes sense.
But in the finite amount of time it takes Achilles to run those 10 meters, The tortoise has continued moving forward, let's say, by 1 meter.
Okay, so Achilles reaches the starting line, but he is still behind.
Now, Achilles has to run that 1 meter to catch up to the tortoise's new position. But while he runs that 1 meter, the tortoise moves forward 10 centimeters.
Now, Achilles has to run the 10 centimeters.
While he does, the tortoise moves 1 centimeter and on into infinity.
Right, because the physical space between them can always be divided into increasingly smaller, infinite fractional slices. A half, a quarter, an eighth, a 16th. Achilles has to complete an infinite number of distinct tasks to catch up.
And Zeno says you cannot complete an infinite number of tasks in a finite amount of time. Therefore, the race never ends, motion is a mathematical impossibility, and everything we see with our eyes is a hallucination.
It's a really frustrating trap.
Zeno used the assumption of infinite divisibility, the idea of a smooth, continuous universe, to completely break reality. Now, the intellectual crisis is, how do we fix it?
The historical record details two completely different solutions to this paradox.
Right. Aristotle, a few generations later, solved it mathematically, using the concept of what we now call a convergent infinite series.
Okay, break down the math fix. How does Aristotle let Achilles win the race?
Aristotle realized that an infinite series of increasingly smaller distances can actually sum to a finite total. Yes, there are infinite steps, but the time it takes Achilles to cross each successively smaller distance also gets infinitely smaller.
So the time slices shrink proportionally to the space slices.
Exactly. When you add up that infinite series of shrinking time fractions, they converge on a finite amount of time. Achilles catches the tortoise in, say, 12 seconds.
This mathematical concept eventually becomes the foundation of modern calculus.
It does. So Aristotle says, the math works out, don't worry about it.
But Democritus and the atomists had a completely different, physically grounded solution that didn't rely on abstract math tricks.
Yes. The atomists solved the paradox by simply denying Zeno's foundational premise. They said Zeno's trap is an illusion because space and matter cannot be infinitely divided.
You cannot keep slicing the distance between Achilles and the tortoise forever.
Eventually, you hit the fundamental, indivisible grain of space. You hit the atomic limit. You can't divide a distance smaller than 1 atom of space.
So once Achilles is 1 atom away from the tortoise, the next step just bridges the gap completely.
They found the absolute bottom floor of reality.
Precisely. Let's look at a physical example that is easier to grasp. A drop of water.
Okay, water.
If you follow Aristotle and Zeno's continuous universe, you can cut a drop of water in half forever, and you always just have a smaller and smaller amount of water.
But the atomists said no.
Right. You can cut a drop of water in half, and you have 2 smaller drops. You can cut those in half. But you cannot do this endlessly.
Eventually, you get down to a single isolated molecule of H2O.
Exactly. If you cut that molecule, you don't have water anymore. You have hydrogen and oxygen. You have fundamentally destroyed the substance.
There is a granular physical limit to water.
And the atomists applied this exact logic to rocks, to air, to light, and to space itself.
So we have this stunningly elegant, logically sound, incredibly powerful theory of a granular universe. It solves the math problem of 0 dimensions. It elegantly defeats Zeno's paradox of motion. It explains how different substances are made via the alphabet metaphor.
It's an absolute masterpiece of human thought.
But in the history of science, it was still just a philosophical deduction. They couldn't prove it physically.
How long did Democritus's idea sit in the waiting room before someone actually proved, with hard physical evidence, that he was right?
It waited a staggering 2,300 years.
That is an unimaginably long time to wait for peer review. 2 millennia of wondering if the foundational theory of reality was actually true.
It is. And what's truly fascinating is that even up to the very end of the 19th century and the dawn of the 20th century, the era of steam engines, railroads, and early electricity, a massive portion of the scientific establishment still did not believe atoms were literally real.
Wait, really? In the late 1800s, scientists still thought atoms were fake? I thought chemistry was already heavily using the periodic table by then.
They were.
John Dalton had already proposed atomic weights, right?
You're right, chemistry was actively using the concept of atoms. Chemists found them incredibly useful for predicting how elements combine.
So why the pushback?
Because many leading theoretical physicists viewed atoms merely as convenient mathematical fictions. They were seen as accounting placeholders used to balance chemical equations, not actual tangible physical objects that existed in space.
That is bizarre to think about now.
The prevailing scientific philosophy of the late 19th century was positivism, which argued that science should only deal with what can be directly observed and measured.
So if you can't see it, it's not physics.
Exactly. There was a famous, highly influential physicist and philosopher named Ernst Mach. He was a brilliant thinker whose ideas on relativity actually heavily influenced Einstein later on.
Oh, I know the name Mach, like Mach speed.
Exactly. But Mach was vehemently, aggressively anti-atom. In 1897, during a lecture in Vienna by another physicist who was using atomic theory, Mach reportedly shouted loudly from the audience, "I do not believe that atoms exist."
That is some intense academic drama.
It was a very heated debate.
Why were physicists like Mach so incredibly resistant? Was it purely the lack of visual proof under a microscope?
It was the lack of empirical measurement, the argument was. If we cannot see them, and if we can never measure their specific mass or their physical size, then they belong to the realm of metaphysics, not hard physics.
That's a fair point for a strict empiricist.
Critics constantly pointed out that Democritus and even modern chemists never gave an exact dimension for the atom. The critics said, if these things are real, how big are they? Tell me the diameter. And no one had an answer.
Until a 25-year-old kid who couldn't even get a job as a low-level university professor showed up and permanently wrecked the entire anti-atom debate.
Enter Albert Einstein.
The year is 1905, often called his Annus Mirabilis, or miracle year.
Right, he's working as a third-class clerk in a patent office in Bern, Switzerland.
Because he couldn't secure an academic post anywhere. But in his spare time, between reviewing patents for electromechanical devices, he is thinking deeply about the fundamental laws of physics.
And in that single year, he publishes 4 papers that completely revolutionize our understanding of the universe.
We all know the special relativity paper, E=mc², but the paper that finally provided the definitive, mathematical, incontrovertible proof of the atomic hypothesis was on a completely different topic.
Einstein proved the atom.
How did he do it? He didn't have a massive laboratory or a particle collider hidden in the patent office.
He used pure theoretical genius, statistical mechanics, and a strange physical phenomenon that had been observed decades earlier by a Scottish botanist named Robert Brown.
Ah, Brownian motion.
Yes, the phenomenon is known as Brownian motion. In 1827, Robert Brown was looking through a microscope at a fluid. Specifically, he was observing tiny grains of pollen suspended in still water.
Okay.
And he noticed something incredibly strange. The pollen grains did not sit still, they jittered.
Jittered.
They danced around in frantic, chaotic, random zigzags, slowly drifting from their starting point.
I've actually seen videos of this from high school biology classes. If you look at dust or pollen under a microscope in a liquid, it looks like the dust specks are alive. They're twitching and vibrating constantly.
It's mesmerizing to watch.
Initially, didn't Brown think he had discovered the life force of the pollen?
He did. He initially thought the pollen was swimming. But then he tested it with inorganic matter, finely ground glass, and even dust from ancient sphinxes in Egypt.
And what happened?
The glass dust jittered exactly the same way. It wasn't alive, it was a physical mechanism of the fluid. But for nearly 80 years, no one could explain why it was happening.
Then Einstein had a genius realization.
What did he see that others missed?
He imagined the fluid, the water, not as a smooth, continuous syrup, but precisely as Democritus had described, as a chaotic swarm of individual, discrete, granular molecules.
The granular universe in action. But how does a granular fluid explain the jittering of the pollen?
Let's look at the sheer numbers. There are billions of water molecules bombarding that single piece of pollen from all sides every single second.
Okay.
Now, if water were a truly continuous fluid, or if water molecules were infinitely small and infinite in number, then the physical impacts on the left side of the pollen would exactly perfectly balance the impacts on the right side at every single microsecond.
The forces would cancel out perfectly.
Exactly, yielding a net force of 0, and the pollen would remain dead still.
Okay, let's use an analogy to really visualize the mechanics of this because it's brilliant. Imagine you were standing perfectly still in the middle of a massive football stadium.
Okay, I'm in the stadium.
You represent the piece of pollen. And swarming around you are millions and millions of tiny blindfolded mice running around randomly and bumping into you.
Millions of mice.
Those mice represent the infinitely small molecules of a continuous fluid. Because the mice are so incredibly tiny, and there are millions of them, the thousands of tiny bumps against your left leg are perfectly balanced by the thousands of tiny bumps against your right leg.
Right. I don't move an inch. I just feel a uniform, steady pressure.
That is a perfect visualization of a continuous, infinite fluid. The averages always balance out. But what if the fluid is not continuous?
What if it's made of finite, discrete atoms that have a real substantial size?
Right. If the fluid is granular, you aren't standing in a crowd of millions of tiny mice. You are standing in a mosh pit with 50 massive, hulking linebackers.
That is a terrifying thought, but a great analogy.
Because there is a finite number of them, and they're relatively large, the collisions do not perfectly balance out every second.
By pure random chance, in 1 microsecond, 3 linebackers might slam into your left side and only one hits your right side. What happens? You get violently shoved to the right.
And in the very next microsecond, just by random statistical variation, 2 linebackers hit your right side and none hit your left, so you get shoved back to the left.
You start jittering. You start doing the chaotic, random zigzag dance of Brownian motion.
The jittering pollen proved, visibly, that the fluid was made of linebackers' finite granular atoms, not an infinite smooth soup of mice.
The precise scientific term Einstein focused on is statistical fluctuations. Because the molecules are finite in size and finite in number, the collisions fluctuate away from the average.
They don't cancel out perfectly in the short term.
And here's where Einstein elevated this from a brilliant conceptual observation to hard, indisputable physics. He applied rigorous statistical mathematics to this random jittering.
He realized that the extent of the jittering, how far the pollen grain drifted in its random walk over a specific amount of time, was directly mathematically related to the size of the invisible molecules hitting it.
He reverse-engineered the linebackers from the movement of the pollen.
He absolutely did. By measuring the visible movement of the large pollen grain and calculated the temperature and viscosity of the fluid, his equations could calculate the exact size of the unseen water molecules that were doing the shoving.
He put hard, precise numbers on Democritus's ancient abstract atoms.
Within a few years, experimental physicist Jean Perrin conducted the exact measurements Einstein's paper called for, and they calculated Avogadro's number and the physical dimensions of the atom.
It was absolute mathematical vindication 2,300 years after Leucippus sailed to Abdera. Matter is granular.
That is one of the most satisfying historical arcs in all of science. Einstein finally closes the loop, started in ancient Greece.
But as I'm thinking about this massive timeline, a glaring historical mystery pops into my head. Let's look at the chain of custody of this idea. We established earlier that the physical city of Miletus was burned down by the Persians.
Right.
We established that Plato and Aristotle, the two most heavily read and preserved philosophers in Western history, hated the atomists and championed a teleological, purpose-driven universe.
And we know that Democritus's dozens of books were entirely lost to history.
Yes, it's a staggering loss. Not a single original manuscript by Democritus survived antiquity.
So, how did Einstein or Newton or Galileo or anyone in the modern era even know what Democritus had said? If his physical books were gone and his intellectual enemies wrote the history books that survived, how did the atomic hypothesis survive the Dark Ages?
That is one of the most dramatic, improbable stories in the history of literature and science. The loss of Democritus's work is considered by historians to be an unmitigated intellectual tragedy.
It's devastating to think about what was lost. We have all of Aristotle's major works, which, let's be honest, held physics and astronomy back by centuries with the whole Earth-centric model and the concept of celestial spheres.
Yeah, but we have none of Democritus's physics. How did we lose it all? Was it just the decay of papyrus over time?
No, it wasn't just passive decay. It was active, systemic suppression.
Okay, we need to be clear about this part.
According to the historical context, the dominant worldview that eventually took hold in Europe, specifically the medieval Christian fundamentalist worldview, was systematically inherently hostile to the philosophical implications of Democritus's universe.
And to be clear to you, the listener, we are neutrally reporting the historical events as they occurred in our source text. The prevailing religious and political authorities of that era had a very specific narrative about the universe they were enforcing.
And they viewed competing narratives as dangerous heresies. We can look at historical turning points, such as the edicts of the Roman Emperor Theodosius in 390 and 391 AD.
What did those edicts do?
They declared a specific brand of Christianity as the sole mandatory religion of the empire, and led to the fierce, sometimes violent repression of pagan texts, temples, and philosophical schools.
Right, it was a matter of theological survival.
Exactly. The dominant medieval ideology could tolerate Plato and Aristotle because their philosophies could be adapted. Aristotle believed in a prime mover, an ultimate purpose, and a strict hierarchical reality with the earth and humanity situated at the center of a divine plan.
But Democritus preached a universe of chaotic, random atoms, explicitly denying a divine plan.
Denying a center of the universe and framing humans as just another temporary natural occurrence with no special cosmic status. That was viewed as deeply existentially dangerous.
Consequently, texts promoting naturalism and atomism were not preserved by monks, they were not copied into new manuscripts, they were not protected in libraries, and they were essentially erased from the intellectual landscape of Europe.
So the flame was stamped out once again by ideological suppression. How did it possibly come back?
It survived by the absolute thinnest of threads, carried across centuries, not in a physics textbook, but hidden inside a poem.
A poem.
Yes. The philosophy of Democritus had been adopted and modified by a later Greek philosopher named Epicurus. And centuries later, Epicurus's teachings profoundly inspired a brilliant Roman poet named Lucretius, who lived in the 1st century BC during the Roman Republic.
Lucretius.
Lucretius decided to write a sprawling, beautiful, epic poem in Latin called De Rerum Natura, which translates to On the Nature of Things.
So he takes hardcore, materialistic atomic physics and turns it into verse.
He does, and it is widely considered a literary masterpiece. Lucretius translates the cold, mechanical reality of atoms in the void into a luminous, serene meditation on existence.
That sounds amazing.
He sings about the sea, the sky, the stars, the biology of animals. He writes passionately about how we shouldn't fear death or capricious gods because everything is just the beautiful, eternal recycling of atoms.
He writes that we are all made of heavenly seed, that the earth, the sky, and human beings are all woven from the exact same fundamental material.
He writes, "Nothing can be made from nothing once we see that so. Already we are on the way to what we want to know."
It sounds incredibly poetic and moving, but I have to ask the skeptical question here.
Go for it.
Does reading a poem from antiquity really count as doing science? I mean, it sounds beautiful, but without Einstein's math, without experimental data, isn't it just a lucky philosophical guess wrapped up in pretty verses? Did a poem really save physics?
It's a fantastic critical question, and the answer is a resounding yes, because science is not just a collection of equations.
Right.
Before you can build the math to describe the universe, you need the conceptual framework to even imagine the universe correctly. Lucretius's poem provided a fully realized, incredibly complex alternative universe that directly challenged the claustrophobic, terrifying worldview of the Middle Ages.
He provided the mental architecture that later scientists would use to build their formulas.
Contrast that for us. What did the accepted medieval worldview feel like compared to what Lucretius was offering?
We can look at Dante's Divine Comedy as the prime literary example of the medieval cosmos. Dante's universe is rigid, terrifying, and deeply hierarchical.
The earth is locked, immobile in the center.
Hell is physically located beneath us, a funnel of suffering. The heavens are physically above us, arranged in strict, unbreakable crystalline spheres.
Every single event, every movement happens for a top-down divine reason.
Human beings are smothered under the weight of cosmic judgment, constant fear of eternal damnation, and rigid social and cosmic hierarchies.
It's a universe that feels like a prison, a very beautifully designed, mathematically intricate prison, but a prison nonetheless.
And then imagine being a scholar in that era and reading Lucretius. The paradigm shift is explosive. In Lucretius's universe, there is no center. There is no top or bottom.
There are no fearsome gods demanding obedience or threatening hellfire.
There is just infinite open space and the endless, creative, beautiful dance of nature. It's a universe where humanity isn't at the bottom of a terrifying hierarchy, but is an equal, integrated, natural part of the astonishing web of life.
It was a massive cognitive revolution. It offered a profound, liberating universalism.
Okay, so Lucretius wrote this poem in the time of the Roman Republic. But it was lost too, right? For centuries, no one read it.
It was almost entirely lost. It sat gathering dust, ignored or suppressed, in monastic libraries, largely forgotten by the wider world, until the winter of 1417.
What happened in 1417?
A humanist manuscript hunter named Poggio Bracciolini, a man who obsessively scoured the remote abbeys of Europe searching for lost classical texts, walked into the library of a German monastery and pulled a decaying copy of De Rerum Natura off the shelf.
He literally pulls the atomic universe out of the dark.
He recognizes its immense value immediately. He brings it back to Italy, copies it, and it spreads like wildfire among the intelligentsia.
The rediscovery of this single poem sent an absolute shockwave through Europe. Many historians argue it was the essential philosophical spark that ignited the intellectual renaissance.
The established church recognized the danger and tried repeatedly to ban it. The Synod of Florence banned it in 1516. The Council of Trent banned it in 1551.
But the newly invented printing press had already done its work. The genie was permanently out of the bottle.
And its impact wasn't limited to scientists. It permeated the entire culture. You mentioned earlier that it influenced Shakespeare.
Yes. A century after its rediscovery, the idea of the atom had thoroughly infiltrated popular culture. In Shakespeare's Romeo and Juliet, written in the 1590s, Mercutio delivers his famous manic speech about Queen Mab.
The fairy who brings dreams to sleeping men.
Right. And what does he say her chariot is made of? He says she rides in a chariot drawn by a team of little atomies flying over men's noses.
The language of ancient Greek physics had become the language of English poetry.
That is incredible.
Yeah.
And of course, it paved the conceptual runway for the titans of modern science.
Exactly. The ripple effect is undeniable. Michel de Montaigne quoted Lucretius endlessly in his essays. Baruch Spinoza's philosophy was deeply influenced by it. Galileo, Kepler, and Newton all read it.
When Isaac Newton formulated his laws of motion, he built them explicitly on the conceptual foundation that Lucretius had preserved. The revolutionary idea of free bodies moving endlessly through an infinite void.
Because without the void, there is no inertia.
Furthermore, Lucretius even provided a living proof of atoms in the poem centuries before Einstein did the math.
Wait, Lucretius proved Brownian motion in a poem.
In a vivid, poetic, descriptive sense, yes. Lucretius told his readers to do a simple thought experiment that they could verify with their own eyes. He said, go into a dark room and let a single bright beam of sunlight shine through a crack in the shutters.
What do you see?
You see dust motes illuminated in the beam.
Yeah.
And if you watch them closely, they are swirling, crashing, fighting, darting in every direction, even when the air in the room is perfectly still.
Lucretius deduced and wrote that this chaotic, visible dance of the dust is driven by the invisible underlying collisions of atoms. The hidden reality pushes the visible reality.
Einstein simply took that exact ancient image, applied a microscope to it, and used statistical calculus to prove it.
That honestly gives me chills. A Roman poet staring at a sunbeam in a dark room 2,000 years ago, accurately deducing the fundamental kinetic mechanics of the universe.
Hiding that knowledge in a poem.
Surviving the collapse of empires and the Dark Ages, and passing that torch all the way to Albert Einstein in a Swiss patent office. It is the greatest intellectual relay race in the history of the human species.
It truly is. Which brings us back to the present day and the synthesis of everything we've explored.
We have traveled an immense distance on this deep dive. We started in the bustling cosmopolitan markets of ancient Miletus, where human beings first decided to look for the mechanisms behind the curtain of myth.
We walked with Democritus as he logically deduced that the universe cannot be a smooth, infinite illusion.
We watched Zeno try to break reality with an infinite tortoise race, only to be defeated by the concept of the atomic physical limit.
We saw Einstein finally mathematically prove the existence of the atom by watching particles dance in water.
And we traced the miraculous survival of this entire paradigm through the beautiful poetry of Lucretius, defying centuries of suppression to spark the Renaissance.
And the ultimate takeaway from all of this history, the golden, unbreakable thread connecting Anaximander to Democritus to Einstein to modern physicists, is the concept of granularity.
The universe is not a continuous, infinitely divisible syrup. It is pixelated. It is made of fundamental, indivisible building blocks. There is a hard, physical, mathematical limit to how small things can get.
But I want to make sure we answer the most important question for you, the listener, right now. Why does this matter today?
Right. Why should we care about an ancient atomic hypothesis when we have smartphones and space telescopes? What is the actual connection to modern quantum gravity?
Because the concept of granularity is the only thing that keeps modern physics from collapsing into mathematical nonsense. Let me explain how it works.
Okay, lay it on us.
Currently, we have two incredibly successful theories of the universe. General relativity, which explains gravity and the massive scale of the cosmos, and quantum mechanics, which explains the tiny subatomic world.
But they hate each other.
They really do. They don't work together.
Why do they conflict?
Because general relativity assumes that space is a smooth, continuous, infinitely divisible fabric. It assumes Zeno was right about space.
Ah.
But quantum mechanics relies on discrete, chunky, granular energy levels. When theoretical physicists try to combine these two theories, when they try to calculate the quantum fields of gravity down to infinitely small distances, the equations spit out infinity.
And the math blows up.
It predicts infinite energy, which is physically impossible. This is known as a mathematical divergence, and it means your theory is broken. Infinity breaks the equations.
So how does Democritus save the day?
By providing the cutoff, theoretical physicists today working on loop quantum gravity, which Carlo Rovelli pioneers, realized they have to apply Democritus's idea not just to matter, but to space itself.
They theorized that space is not a smooth, continuous box that atoms move around inside. Space itself is made of atoms.
It is a network of tiny, indivisible, discrete loops of gravitational field.
Space has pixels.
Exactly. Quanta of volume. There is the smallest possible size of space, called the Planck length. You cannot divide space smaller than a Planck length.
And because space cannot be infinitely divided, the equations of quantum gravity never reach zero distance.
Therefore, the energy never goes to infinity. The mathematics are saved by the granular limit. Democritus's ancient philosophical deduction is the exact mechanism preventing modern physics from breaking down today.
That is absolutely mind-expanding. The uncuttable pixel saves the universe. Which leads me to one final, provocative thought. Something to just let marinate in your brain after you finish listening today.
I love these. What is it?
We have spent this entire deep dive talking about slicing things up. Slicing a rock, slicing a drop of water, slicing the distance between Achilles and the tortoise, and finally, slicing space itself.
We found the atom, the fundamental indivisible chunk of space and matter.
But what about time?
The absolute ultimate frontier.
If space has a pixel size, if matter has a fundamental limit, does time also have a smallest possible tick? We experience time as a smooth, continuous flow, like a river carrying us forward. But what if it's not? What if time is granular, too?
Are we actually living our lives in a smooth, unbroken flow, or are we just experiencing billions of tiny, indivisible frozen frames per second?
Clicking past one another so incredibly fast that human consciousness creates the illusion of smooth motion.
A quantum of time. The Planck time. It is the exact same logic Democritus applied to the rock, now applied to the clock.
Exactly. Just something for you to mull over the next time you are sitting in a quiet room watching a dust mote dancing in a sunbeam. Remember that you aren't just looking at dust, you are looking at the invisible, granular machinery of the cosmos.
The very machinery that was first imagined in the dust of ancient Greece.
And the machinery that holds the entire universe together. Thank you so much for joining us on this deep dive. Keep questioning the reality around you, keep looking for the underlying patterns, and we'll catch you next time.